Hello, my name is Emmanuel Adu-Sarkodee, and I'm presenting on my project, which is called Plastic Econ Database. We'll be going through what the company is about, ER diagram, logical table derivation process, SQL keys, constraints, preferential integrity, and indexes. And we'll also cover the queries. So let me go back and actually tell you what this company is about. So this company deals in recycling of plastics. What they do is that they collect plastics from every single home and they recycle that into new products. So that's their main one of their mission is to help reduce plastic is to help reduce the occurrence of plastics in our communities. But their main aim is to make profits. Like the main aim is to actually make profit as a company, and we'll delve into that later. So now let's go straight and look at our ER diagram. So it has a head office, and each head office has a company branch. So that's sort of what we're working from. And each company branch has a collection track, which will then go to a collection site. But the collection site is basically the location of the house it goes to collect plastics. So it collects the plastics from the homes, from each home in the collection site, and the plastics from home is sent back to the company branch to be recycled. So it's sort of like it's sent to the company branch and it makes recycled plastic. So now how they know one of their what I mentioned as their vision earlier on to know if they are really recycling is that they go to companies producing plastics like Vena, Belacqua, Voltic, and the like and ask them, oh, for the month of January, how much plastic are you going to produce? 50 kilograms, 1,000 pounds of plastic. And so at the end of all this, when they finish recycling, they would compare how much their company has produced with how much they've recycled and be like, oh, out of the total production of plastic, which is 100 kilos, we're able to recycle 80. So now this recycled plastic is then sorted into plastic categories. And this plastic category is sold to make plastic sales, which is their final aim. Of course, their relationships. So, for example, one track will have to visit one collection site to prevent multiple collection tracks from visiting many collection sites at this. To prevent multiple collection tracks, to visit the same many collection sites so that there's no confusion and other relationships are defined. Now, this is what the DBMS will do. Provide a means of comparing the plastic produced to the plastic recycled, provide an avenue to know which companies are owing after sales, provide an avenue to know their most productive branch. They also provide an avenue where all cash collections as well as cash deductions are sorted, provide a system to sort out locations throughout Africa because their companies are located in Africa. So the progress made in terms of plastic produced versus plastic recycled is specific to communities in a country. So lastly, provide a system whereby the sale of recycled plastic is recorded and analyzed. So we have to keep this in mind because this is what we use to build our SQL queries. Yes. So this is how we've derived our tables for the SQL code actually. So we have a company branch. Primary key is so actually all primary keys are bold and underlined, and foreign keys are italicized. So yes, and we have the collection site. You saw that in the ER diagram. Collection sites consist of the country, city, and the street address. So this collectively forms a composite primary key to define the collection site. Of course, track will have a track vehicle identification number, and we'll also have to have foreign keys. And yeah, every table will have its own entities, and all the entities are the primary keys are all bold and underlined, and all foreign keys are italicized. So it's we'll see that properly in the SQL code. So now we have some constraints, of course, like we can't really enter anything we want. So we have to apply some constraints. So for example, we have our branch location, right? Our branch location has to be unique. This is because every single branch is located in a particular community. So a branch would then operate, you know, a branch would then operate independently, have its own tracks that will send to different locations to um, um, engage in the recycling process. So yes, it'll have to be unique. And also maybe a country when collection sites, which I would talk about, which I spoke about earlier on, sorry, will have to be not now. Yes. Um, Now we'll go to our referential integrity. So branch ID is actually our primary key for company branch. So we want to use it in the collection track because a collection track is from where? A branch. So we want to bring that branch ID here. But we have to use declare it as a foreign key because it's a foreign key inside the company branch. So we have to put this here accordingly. Yeah. So now indexes will be important because if we have a lot of data, we need to know exactly we need to be able to sub-classify them to what we really want. And these indexes will actually be necessary for our query creation. So we have our first one, which will create an index called price amount received on plastic sales, which will have the price and amount received. And we'll be used to know which company owes plastic e-com. So the price it was sold for will be stated and amount received, so it will be subtracted. Again, a main aim of the company is to make profits. So this is very important. And also, cash collected will be compared with house plastic to know if a truck driver is stealing. So if cash, so there was also, oh, I forgot to mention a very important thing. So houses that don't have plastic, in collaboration with the government, would actually be fined a flat rate of 50 US dollars. So if cash collected, right, is saying um, 50 CDs, and then if cash collected is saying sorry zero, and has plastic is saying yes, has plastic is saying no sorry, then we'll know that there's something wrong, that the truck driver is actually was being honest. So we'll have to create indexes on those things. And um, last but one, we need to know how to assign tracks to a particular location. So we have to collect the collection sites, index on the collection site, which is the country, city, and the street address. And lastly, have the um, plastic produced weight, which will be compared with the total amount of plastic recycled. So how much progress the company is making. I spoke about this early on. So we just have to get an index on plastic produce, on company producing plastic, their weight. So um, we'll go to the actual queries later on. And all these tables are actually already defined here. But let's go to the SQL code. So now we have our tables as declared here. The company branch table, the collection size, the collection track, and recycled plastic and plastic sales and all that was in the ER diagram. And so now we have these queries. So um, this query actually solved the problem of comparing plastic to recycled plastic. So we'll have an outer join of recycled plastic on company plastic, the weight, and the total recycled plastic. So we'll just display both of those tables, and we'll have to know who the recycled plastic was sold to. So plastic categories dot serial num from plastic categories, and we inner join those two to know that. And we need to know um, which companies are owing after sales. Very important because of the aim of the company. And we'll sum this and we'll see this as companies owing from plastic sales. Lastly, we need to know the branch with the highest recycled plastic output. So branch ID and HP weights would be needed from plastic home or order by HP weights, so that we'll know the branch which has the highest recycled plastic output, hence the ability to create more sales. So I guess that would be all, and thank you very much.